we're going to do exponents, and we are also going to do what we call the surds. So these are some of the things that we are going to understand, or that we are going to do today, right? Now, in order for us to understand what exponents are, we are going to start by firstly understanding what we call our exponential laws, right? So we are going to understand our laws of exponents. So we are going to understand the laws of exponents. Right. To just take a quick overview in terms of what were some of the laws of exponents that we know, and some of the things that we might have learned on the previous grade, right? So now we are going to start with the first one. So we are going to start by now our first one, which is the one that states now, if you are having x to the power of n. So the first one, which states that now, if you are having x to the power of n multiplied by x to the power of m, this is going to be, so basically, which means when you multiply powers of the same base, what you're going to do, this is going to be x to the power of n plus m, which means when you're multiplying powers of the same base, you do what? You add the exponent. So basically, that's what the first law means. So now the second one, which is your second one, is that now, basically now, if you are going to divide also powers of the same base, what you're going to do is you're going to subtract the exponent. So this is going to be x to the power of n subtract m. So which means now when you're dividing powers of the same base, you are going to subtract the exponents. And now the third one, which is now, when you are going to multiply, let's say x to the power of n close brackets to the power of m. So this is going to be, now when you're multiplying an exponent with an exponent, this is going to be same as now x to the power of n and m, which means it's going to be your n multiplied by m, which means it's going to be that exponent of x multiplied by that exponent of m, right? So basically that's going to be that. Now let's look at let's say our fourth law, the fourth law of exponents that we might remember. So now we are saying, if you are having x to the power of 0, what is x to the power of 0? X to the power of 0 is equals to 1. This is given by 1. And the fifth one, which means now, for example, if you can have x to the power of -1, x to the power of -1 can also be given as 1 over x. And remember, this x, this power x, let me just get a different color. This power x means here, it's same as 2 the power of 1, even though we don't write this one, but here it means it's same to the power of 1. Oh, it's okay. So, which means when you're having a negative exponent, now this can also be written as 1 over that particular exponent, right? So now let's look at our sixth law now, which now can be, now we are saying, we can also now, let's say now you're having, let's say, if you can just put this more into perspective, that now, let's say you are having, or you are given that you have x to the power of -n. This is going to be equals to what? This is going to be 1 over x to the power of n, which means a negative exponent can be also written as 1 over x to the power of n as a positive exponent, right? And our law number 7, which now can be, now let's say you are given that you have a root. Now here you are having m, and then here you're having x to the power of what? Of n. This can be given as what? This is going to be x to the power of what? To the power of n over m, which means this basically means here. This means now, for example, what happened here is that this n here, this n here is going to become this one, which is your numerator, and whatever that is here, it's going to then become the second fraction, which we have written here. So this is what your law of exponents state. Now let's now continue. Let's go to another page. Now so now let's add a new page. The law, which states now that if you have anything to the power of 0, this will always be given by what? This is going to always be given by 1. So which means now, if let's say you have a number 1,000, if you have a number 1,000 or 1,000,000, that is to the power of 1 or to the power of 0, is always going to be equals to 1. So we are saying anything to the power of 0 is equals to 1. And we are also now saying, for example, now, if let's say now, the second rule is that, let's say you are having your root of, we are saying we are having x to the power of a. Let's write this nicely. If let's say you are having x to the power of a plus b. So x to the power of a plus b. This means now this a plus b is going to be distributed in all the x, which means this is actually the same as what? X to the power of a plus what? Or rather multiply, not plus. This is going to be x. This is going to be x to the power of a multiplied by x to the power of b. Right. So we are also saying that now. Also, we are saying, let's say you are having your root of x to the power of 3. Now, how can this can also be written? Now, this can also be broken down into what? This can also be broken down into, this is the same as x to the power of 2 multiplied by x to the power of 1. Remember that when you're multiplying powers of the same base, you do what? You add the exponent. So this is still same as x to the power of 3. And also, now we are saying now, for example, if you can have let's say now you are having x to the power of a multiplied by what? X to the power of b. This can be written as, or this is same as now, x to the power of a multiplied by the root of x to the power of b. Now, these are one and the same thing, right? So, which means if you're having x to the power of a multiplied by x to the power of b, these can also be separated, as this will mean one and the same thing, right? So, let's make up our space here. So, now, let's see. Now, we are also saying, for example, this, if, let's say you are having root of x to the power of 2 multiplied by x to the power of 1. This is same as what? This can actually be written as, this is going to be same as x to the power of 2. And remember here, what this means. Remember, this root here, let me use a different color. This root here, actually, this root here, remember, when there is nothing here, it's actually same as 2, right? So which means this is 2. Actually, this means it is also 2. So this can also be written as actually x, which is also x to the power of what? X to the power of 1, which means this root here is going to cancel out with this 2. And then you are going to have what? X to the power of 1, which is same as x. Right? And another law of exponents state that now, for example, if you are having your 2 here and you're having your a, which is to the power of 1, this can still be written as a to the power of 1 over 2, right? So this is some of our laws of exponents that we have. And this is very important when comes to all this, or when it comes to set exponents that we are going to be examining for our grade 11 content. Now let's now add more page, and then let's see. terms of what can we do. Let's minimize this here. You are given that you have into bracket -7 close brackets to the power of 0 plus you are having 8 which is also 2/3. Now they say solve this. Now remember that we said firstly we said anything to the power of 0, anything to the power of 0, anything to the power of 0 here, anything to the power of 0 is what? It's same as 1. We are saying anything to the power of 0, it's same as 1. So which means now from here, this is this can be written as what? This is going to be equals to 1 plus, and then this other one, it's same as what? What can you do? Remember that your 8 can be written as 2 to the power of 3 close bracket. This is going to be 2 over 3 also. And what that means, this is basically going to be this is same as you are multiplying the exponents. So if you are multiplying the exponents, this is same as 3/1, which is the one that within the bracket, multiplied by what? Multiplied by 2/3. And what will happen here is that you are going to say, what is 3 multiplied by? What is 3 multiplied by 2? This is going to be 6. What is 3 multiplied by 1, which is 3? And this can be given by what? This can be given by 2, right? Or if you don't want to do that, you can simply just say this here is going to cancel this one. And then you are going to have, which means what you are having here is going to be equals to 1 plus 2 to the power of what? To the power of 2. And what is 2 to the power of 2? This can be given as what? 2 to the power of, this is 1 plus 4, which can be given as 5, right? This is just, you know, an example involving some of our exponents and our exponential laws, right? Now, let's, I want us to dig deeper and look at some of the more examples that involves, you know, some of these basic things so that we can grasp in terms of what is these laws of exponents and how do they assist us in mathematics generally, right? Now, similarly, let's just take another basic example. Let's say this is our example 2. We are having our example 2. So for our example 2, let's say now you are given, let's say you are given that you are having what? You are having this, which is 2 to the power of, or 2x negative 2 to the power of 3. And then you divide this by what? By 2, which is x to the power of negative 3, all to the power of 4. And then we want to find out in terms of what is going to be this. Now, firstly, what is going to happen is that this negative 2, rather this 3, is going to be applicable to everything within this bracket, right? So which means, this means that this is going to be 2, it's going to be 2 multiplied by what? 2 to the power of 3 multiplied by what? What is 2 negative 2 multiplied by 3? This is going to be x to the power of negative 6 divided by what? This is going to be divided by same thing that is going to apply here, which means this is going to be 2 to the power of 4 multiplied by x, which is going to be negative 12. And yes, this is going to be negative 12. And what that means is, now what we can do is, now we are having powers of the same base, right? So let's continue here. We are having powers of the same base. So which means we can now take also, we can now take and say, this is powers of the same base. You are going to subtract the exponent. So this is actually same as 2 to the power of 3, subtract 4, multiplied by x to the power of negative 6, plus 12. Plus 12. Remember that it is negative 12. So if this is negative 12, as soon as you move it into your numerator, it's going to be positive, right? So this is going to be same as 2 to the power of negative 1 multiplied by x to the power of 6, and which means this can be written, remember from our law of exponent, we said this can be written as a positive exponent, right? So which means you are going to have x to the power of 6 over 2. Remember, this is same as 2 to the power of 1. And 2 to the power of 1 is same as 2. Altogether. So this is some of, some of these basic examples that we are going to consider moving onward with this, so that we are not going to experience or encounter some of the problems, right? So now let's add just a page. Now let's say now we are going to some of the things now. Let's add a page. Question, they say simplify. Now what is it that you are going to do to simplify? Let's say you are given this, you're having x to the power of, let's say you are given that you have 8 to the power of x minus 1 multiplied by 3, which is going to be negative x minus 1. Now we are saying now, this is divided by 1 over 4, which is also negative x, multiplied by 6 to the power of negative x minus 3, multiplied by 9 to the power of 1, subtract x, right? Now we are saying firstly, you need to simplify this. Let's extend our line here. They say simplify this. So what is it that we can do to simplify this? Hopefully this is visible. Now what we can do firstly is we need to start, we have one of some of the rules here that we need to follow, right? Which is your first rule is here at the tip, so that you can forget. The first thing is you're going to find the prime factors, right? You're going to find prime factors. Then the second one, this is your first one. The second thing that you're going to do after finding prime factors is you're going to multiply. You're going to multiply your exponents in brackets. Exponents in brackets. So these are some of the things that you are going to do. So let's see. So what we are going to do is we are going to find out what is the prime factor of 8. Remember that your 8 can be written as what? This 8 can be written as 2 to the power of 3, because 2 to the power of 3 is same as 8. So this is x subtract 1. X subtract 1 multiply by this is same as 3 to the power of negative x subtract 1, because here there is no prime factor, right? Now we divide. So we are dividing what? 1 over, what is 4? 4 can be written as 2 to the power of 2. And this, which means this is going to be 2 to the power of 2 to the power of negative x multiplied by, now here, we then need to change in terms of what is the prime factor of 6? 6, we know that 6 actually it's same as 2 multiplied by 3. And 2 multiplied by 3 to the power of x subtract 3. And I think you might have remember from some of the rules that we did earlier, that which means this x subtracts 3 is going to be applicable to this 2, and this x subtract 3 is also going to be applicable to this one, right? So let's extend our line here. So now, and then from here, we are saying, what is it that we can also do? We can look at the 9. What is 9? 9 can be written as what? 9 is same as 3 to the power of 2. So which means basically this is 1, also subtract x, right? So let's just add here. So now in solving this, we are going to say this is going to still be given as what? Now remember that everything that is here is going to be applicable here, right? So what that means, this basically means now we are going to have 2 to the power of 3x subtract what? Subtract 3, because this is going to be 3 multiplied by x, 3 multiplied by -1 also, right? Multiplied by, what is the second one? This is still 3 to the power of -x subtract 1, because there's nothing there that we have done. So now in our denominator, what we are going to have is, for example, remember that 1 over, let me write it here. Remember that 1 over 2 squared can still be written as what? As 2 to the power of -2. Remember, then you can change this into a negative exponent. So which means what we are going to have here, this is going to be written as 2, which means this is going to be 2 to the power of -2, right? And what is 2 to the power of -2? It's same as that thing, which is 1 over 2 to the power of 2 squared. Then this is going to be multiplied by, and remember here that everything here is going to be multiplied by this, right? So which means you're going to have 2 to the power of x subtract 3 multiplied by 3, which is same as what? Which is same as x subtract 3 multiplied by what? What is the last one? This last one is same as also 3 to the power of 2 subtract x. I mean subtract 2x. It must be subtract 2x. Let me write this. This is 3 to the power of 2 subtract 2x, because even there we are still multiplying. And then now from here, then you can use the law of exponents to now take everything here. So let me try and, use another color so that we can see what we are referring to. So now you can start with everything that have a 2. You see everything that has a denominator of 2, it's this, and also this, right? So which means this is going to be your numerator, and this is division. This is under your line, your division line, which means this is going to be subtracted. So actually we are going to have 2 to the power of what? This is same as 2 to the power of 3x subtract 2 mat and then the rest also, this is 2 multiplied by -x, so this is going to be actually positive x. And when you're taking it to your numerator, it's going to be, this is subtract 3, by the way. This is going to be same as plus, or rather this is was plus when it's negative multiplied by negative. So now this must be negative. Let's fix that. This must be negative. So if this must be negative, so which means this is going to be equals to -2 to the power of x. And what else are we going to have here? Then this other one, it's going to be what? And the same thing as -x. And then this is going to be negative. And the negative here, it's going to be +3, because now it's going to be multiplied in the numerator. It's going to be going into your numerator. This is going to be also 3 to the power of -x minus 1 minus x. And this is going to be +2 plus 3 minus 2, because now we are having that, and plus 2x. Look, so what we are saying is you are going to have this, which is -x minus 1, and you are going to have this one now, which is minus, because when this goes to your numerator, it's going to minus. So it's going to be minus x, and this, when it goes to your numerator, it's going to change side to a plus, because when you're dividing powers of the same base, you subtract the exponent. So this is going to be plus, because it's negative already. Negative multiplied by negative is positive. And then also you're going to have -2, and then this is, since this is negative, it's going to be +2. So can you see that in totality, as a result, what you're going to have, you're going to have 2 to the power of, this is 3. This is -2 minus 1. -2, these two are going to give you negative 3x. And you are having positive 3x. Can you see that actually this and this and these are going to cancel each other? And here you're having -3 and +3, which means actually this is 2 to the power of 0. The other one is going to be equals to what? Here it's negative, which is -2x. This gives you -2x. And -2x plus 2x, can you see that these actually are going to cancel out with this one? And then you are going to have what? You are going to have also here 3. and then you are having 3, positive 3, you are having -2 here, you are having -1 here. So which means this is same as multiply by 3 also to the power of 0. And what is this to the power of 0? We know that 0 to the power of 0, it's 1, which means you're having 1 multiplied by 1, which means your answer is still going to be equals to 1. Right now, hopefully this makes sense in terms of how do you simplify some of these expressions. Now let's try and see whether can we not find another example. Now let's look at another example, our example 3. Now let's say you are given that you have 5 to the power of x plus 2. Subtract what? Subtract 5 to the power of x minus 1. Divide by 2 to the power, multiplied by 5 to the power of x. Now, how can you go about solving this? How can you go about solving this, right? So now the first thing that you can do now, in this one, it's a different approach from that old one, which means now as soon as there is a negative sign, it changes everything. So now how can you approach this? Now this is going to be firstly, so which means form of this. Now this 5, it's actually same as 5 to the power of x multiplied by 5 to the power of 2. Subtract what? Subtract 5 to the power of x multiplied by 5 to the power of -1. So this is what you can do in factor form. Now, can you see that from these factors, you are having a common factor? You are having a common factor. You're having a common factor here. And your common factor is 5 to the power of x in this equation. This is common in both of this, right? So let's start by firstly writing our denominator, which was same as 2 to the multiplied by 5 to the power of x. So which means this, what you can do here firstly is you can say, all right, what is this going to be? This is going to be 5 to the power of x. If I take it as a common factor, what am I going to left with? Can you see that you're left with 5 to the power of 2? Subtract what? 5 to the power of -1 because you've taken that one as a common factor. And then we are still dividing by 2 multiplied by 5 to the power of x. And now, can you see that since you are dividing, and then there's a multiplication sign, can you see that this one and these ones are going to cancel, right? These ones, because they are the same, they're going to cancel. So, which means what you're going to be left with here, you're going to be left with 5 to the power of 2, and 5 to the power of 2, we know that this is 25. Subtract, what is this? 5, remember that we said this can be written as a positive exponent. So this is actually 1 over 5. Divide by what? Divide by 2. Right, let's just, and then this, which means now can be also be written as what? Now, which means you need to then start solving this. Let's make up our space here. 25 subtract 1 over 5. How can you simplify that? This is same as now we can now solve for our denominator. And to solve for our denominator, we can try and make this to have the same denominator. So for this to have the same denominator, which means we must multiply by this 5 here, which means we must multiply everything by 5. And remember, when you multiply by 5, you multiply the numerator and the denominator. And 25 is same as 25 over 1. So which means you are going to have what? This is going to be 25. 25. Remember, I said 25 is same as over 1. Multiply by, let's use a different color. 25 multiplied by 5 over 5. Remember, this is multiplied by 5 over 5. And then the other one is going to be what? Subtract 1 over 5. And the same thing here. Remember, what you do on your left, you're also going to do on your right. But automatically, because you have 5 here, so what you can do is, now this is going to be same as 25 over 1 multiplied by 5 over 5, subtract 1 over 5. Actually, you don't have to multiply because your aim was to have the common denominator, and you are having denominator as your 5. So now what is going to be that? This is going to be 125 over what? 125 over 5 let's write this 5 nicely. Subtract 1 over 5. And then when you are having the common denominator now, so which means this can be written under one roof, right? Because they are of the same family. This is going to be 125 subtract 1 over 5. And what is 125 subtract 1? This is 124 over 5, right? 124 over 5. But we must not forget that in our denominator, we still have your 2. The denominator, remember, we haven't solved. Remember, we haven't solved for that too, right? So which means what we then going to have here. So which means we are going to have 124 over 5 divide by this 2. And remember, this 2 is coming from here, because can you see that here we never solve for this 2, and even here we never solve for this 2. That's why this 2 is still also here, and that's why this 2 is also still here. And that's why this 2, it was also in here under 125 subtract 1 over 5 divide by 2. Okay, so I want just to show you in terms of where that 2 comes from. So, and now you can flip and turn, right? So which means this can also be written as 124 over 5 multiplied by 1 over 2. And what is this going to give us? Now, this is going to give us 65. If you have a calculator, this is going to be 62 over 5 as our final answer. So that is as far as this example is concerned.